This video contains all information you need to know before buying your first telescope. The first thing we need to do is to think about what you want to do with your telescope. Do you want to use your telescope purely for visual astronomy, or do you eventually also want to take photographs of the night sky with it? And if you want to take photographs of the night sky, what do you want to photograph? Do you want to photograph the planets? Do you want to photograph the moon? Maybe the sun? Or do you want to photograph galaxies or nebulae? These are all decisions you need to make before buying your first telescope, as every telescope specializes in making one of those choices happen. Of course, there are some telescopes that are more versatile in this regard, but it's very limited. Today I will take you through the choices I made buying my first telescope, and I explain everything there is to know about the different telescopes. Alright, let's start with the first choice. What do I want to do with my telescope? For me, it soon became clear that only visual astronomy is not challenging enough for me, and that I want to pass quickly to astrophotography. This doesn't mean, however, that I never want to look through an eyepiece, and of course I want to see what the moon looks like through my new telescope, and of course I want to see what Jupiter looks like. But my end goal is to do astrophotography with the telescope. If we then look at what do I want to photograph, I quickly realized I like photographing galaxies and nebulae the most. Once you have made the choice, it is important to look at what do I need to make this happen. Yes, you need a telescope, and that's what this video is about, but I also need to tell you quickly about the different mounts for a telescope. Because there are a number of different mounts, and I'm going to name them very briefly, and then I will move on to the telescopes, I promise. First off, you have a ALT-S mount, or an altitude azimuth mount. That means that this mount can move the telescope from top to bottom and from left to right. That sounds ideal, and it is. Just not for astrophotography. For astrophotography, you need a German equatorial mount. And the mount is positioned at the angle of the Earth. And that means that it can move the telescope from north to south instead of up to down. And instead of left to right, it can move the telescope from east to west. This is crucial to be able to track the objects and be able to take longer exposures at a later stage when you are really getting into astrophotography. The third option is a Dobsonian alt-azimuth mount. And a Dobsonian mount is often a long telescope which is very capable for visual use. It is placed on the ground and it can move the telescope from left to right and top to bottom. Alright, telescopes, because that's probably what you are here for. There are three types of telescopes and I'm going to discuss two in more detail. Those are the refractors and reflectors. The third type is a catadioptric, and I just don't know enough about those to say anything useful about it, so I will just leave them for what it is. It's still by and for dummies, so stay with me. So a refractor and a reflector, what are they? What are the advantages? What are the drawbacks? And what did I ultimately choose? We start by discussing refractors. This is because a refractor telescope is the most similar to a camera lens. And what you also see a lot is that people who want to start astrophotography just very wisely start with a slightly larger camera lens and just start making photos with those. But also with camera lenses of already 50 millimeters, you can achieve a lot in astrophotography. But that's not the focus of this video though. We are looking at telescopes. So a refractor works the same as a camera lens. At the beginning of the telescope tube there is a lens, and in some, but those are really already more expensive refractors, there are a number of other lenses in between. And those lenses ensure that the light passes through the eyepiece into, well, your eye. It sounds a bit strange and all, but that's the basic knowledge on how a refractor works. Advantages of refractors are that they are relatively small and compact telescopes, which make them easier to transport. And remember that using a telescope works a lot better under really dark conditions. So setting up a telescope in the middle of Amsterdam Schiphol Airport is great fun and you will see planes fantastically nearby. But the stars and planets that you want to observe, well, you just don't see them, or at least a lot less. Besides the fact that refractors are a lot lighter and therefore easier to transport, refractors are also less affected by the wind. Where a reflector, which is generally a very large telescope, suffers from the wind much more. And make no mistake, a small breath of wind against a large telescope already causes an enormous movement in the image. The last positive point I want to say for the refractor is that a refractor is maintenance friendly. You really don't have to look at them that much. You set them up, you look through it, you put it back and you're done. A reflector telescope needs a little more maintenance. Okay, so sounds all good and fun, but what are the disadvantages of a reflector telescope? First of all, and that's something very important, and it's called chromatic aberration. And I know it's a difficult sounding concept, but I will explain it to you. What it means is that the colors of the light entering the lens of the telescope move scattered throughout the telescope. So the red, green and blue wavelengths move in a slightly different way through your telescope. This mainly occurs with cheaper refractors with lower quality glass. So what does this mean in concrete terms? If you take a photo through a cheap refractor telescope with lower quality lens glass, chromatic aberration takes place. This ensures that you will get colored edges to the stars and that the stars are different in shape. So instead of getting nice round white stars, you will have more oval shaped stars with different colors on the edge. An important note is that this is not only true for photography, but that chromatic aberration also can be seen visually. Then you don't see stars, but you will see ovals with discolorations. Another disadvantage of refractor telescopes is that they can quickly suffer from dew formation on the lens. This mainly occurs on humid nights, so depending on your location, this might apply more or less to you. With dew on the lens, you cannot see through the telescope. And of course there are solutions for this, such as a dew heater. This is a little band that you put around your telescope, which heats this telescope just enough to prevent dew formation. But it quickly means that if you don't want chromatic aberration and you don't want dew formation, that you quickly spend quite a bit of money on your first telescope. And whether that's what you want, well, that's not my choice to make, but it's good to keep in mind. Okay, it's a long set and a lot to take in and to understand all of these concepts, so take it easy, pause the video for a bit, grab a cup of coffee, grab a cookie, take your time, rest a little. Are you back? Great! We move on to reflectors. And a reflector and a refractor work slightly different, but it remains, of course, a telescope. A reflector telescope has a large opening and at the end of the tube sits a mirror. That mirror reflects the light in a smaller mirror and your eyepiece looks into the small mirror. This ensures that you never suffer from chromatic aberration, as you do not have a lens glass, but instead you have a mirror. This means that you can immediately take better pictures by using a reflector telescope that is probably a bit cheaper than the first refractor telescope that you can take a reasonable picture with. A disadvantage of reflectors is that you have to do maintenance on the telescope and especially on the positions of the mirror. It can shift slightly when you transport it a lot, for instance by car, or just shake your telescope even. This results in shifting the mirror. And when the mirror is shifted, it is possible that you can no longer get focus with your telescope. And while you don't have chromatic aberrations in a reflector telescope, you do have something that is called Coma. And Coma is due to the sphericality of the mirror in the telescope, and it affects objects that are further away from the center. So imagine you observe Jupiter and you place it exactly in the middle. Then, of course, the moons are a bit further outside of the image. The Coma effect then occurs on Jupiter's moons. So this ensures not having round stars, but again getting egg-shaped or oval stars. An advantage of a coma compared to a chromatic aberration is that it's only X-shaped instead of X-shaped and discolorations. I personally find this a real advantage. You also have a solution for coma, which is called a coma corrector, although these are often quite expensive. A further disadvantage of a reflector telescope is that it is quite large and heavy compared to a refractor telescope. This makes it more difficult to transport, but also means that it suffers more from wind. So you really need a very sturdy mount for a reflector telescope to keep it stable, especially when you are getting started with astrophotography. Okay, so we've now learned a lot about telescopes, how they work, what types there are, and we heard something about mounts or something. So, how do you search for a telescope? We go all the way back to the beginning of the video and we are revisiting that question, what do you want to do with your telescope? For me that meant I want to do photography and I mainly want to focus on galaxies and nebulae. Planets are a nice bonus if it's possible, but not the main focus for me. What you will then investigate is how big the telescope should be. Because every telescope has something that's called the maximum useful magnification. And the maximum useful magnification does not mean that the telescope cannot magnify any bigger than that useful magnification, but it means that if you go bigger than that useful magnification, the magnification gets blurrier and you will get less detail. Within telescopes, there are three main subjects that determine what a telescope can do. You have the aperture, the focal length, and the focal ratio. And the aperture is the diameter of the telescope. The focal length is the length of a telescope, and the focal ratio is how fast the telescope works. And I always think that how fast a telescope works sounds a bit weird, but I'm going to explain it to you. Okay, so we start with the aperture, and the aperture is what I just said, the diameter of the telescope itself. And you have to think about a telescope the same as a bucket that you put in the rain. The bigger the bucket, the more rain it collects. So, with a telescope, the larger the diameter, the more light it collects. The aperture is also an important variable to determine the maximum useful magnification. The maximum useful magnification is always 2 times the size of the aperture, provided that the aperture is indicated in millimeters. So, if you have an aperture of 150 millimeters, the maximum useful magnification is 300 times. If the aperture is 70 millimeters, the maximum useful magnification is 140 times. Next up, we're going to look at what the focal length is. And the focal length is, as I said before, the length of the telescope. And the focal length affects a number of components, including the focal ratio, but I will get to that later. The length of the telescope determines even more. When you are using your telescope visually, you will put an eyepiece in the telescope where you eventually look through. The size of the eyepiece together with the length of the telescope determine the magnification you see. So, if you have, for example, a telescope that is 1200 millimeters long, so you have a focal length of 1200 millimeters, and if you use a 20 millimeter eyepiece, then you divide these two by each other. So 1200 millimeters divided by 20 millimeters is a 60 time magnification. So you see the object 60 times larger than with the naked eye. This is useful information to determine whether you are not going over your maximum useful magnification with the telescope and eyepieces that you want to use. So as I just said, the focal length also affects the focal ratio, or the F ratio, or the F of a telescope. But what does it mean? The F of a telescope determines two things. First, it determines the width of an image that you can view. A low F stands for a wide view and is good for observing larger objects such as the Andromeda galaxy or for large nebulae. These are gigantic objects in the sky, and with a too large of a magnification, you can never put it all in one picture. A high F automatically means that this is for a narrower image. So this is good for smaller objects like distant galaxies or planets. What an F also determines is the speed of the telescope, and it works the same as with a camera. The lower the F is, the more light on the camera sensor per pixel per second. This means that if you have a telescope with an f4 and you take exactly the same picture as with an f8 telescope, that this picture from an f4 telescope is 4 times brighter than that from the f8 telescope. That means you need 4 times less time for the same picture of a dim object with an f4 telescope than with an f8 telescope. You can calculate an f ratio by dividing the focal length in millimeter, so the length of the telescope in millimeter by the aperture in millimeter. So for example, if you have a focal length of 750 millimeters and you divide that by the aperture of 150 millimeters, then you have a telescope with an f5 ratio. And an f5 ratio is seen as a fast telescope with a relatively wide image. A 1:5 f ratio is seen as fast and wide. Anything from around 5 up to 10 is seen as average. This is where most visual telescopes sit just fine. And anything above f10 is seen as a large f ratio and thus is slow but narrow. Okay, now that we know everything about the different ratios, types of telescopes, the different mounts, and basically everything you need to know to buy a telescope, it remains for me to tell you which telescope I have bought. I went for the Skywatcher Explorer 150p. This is a reflector Newtonian telescope with a focal length of 750 millimeters and an aperture of 150 millimeters. So this means that the maximum useful magnification of my telescope is 300 times and that I have an f ratio of 5. Now, if you go back to that same question I asked in the beginning of the video, what do I want to do with my telescope? Yes, the question keeps coming back. And you see that I looked at, okay, I want to do photography and mainly photograph not too large objects, but not the smallest either. So I went looking for a telescope with a reasonably wide image because, well, nebulae are generally large and galaxies are, well, smaller. So I also need some magnification, but there are also larger galaxies, such as the Andromeda Galaxy or Messier 33 or the Triangulum Galaxy, which is also a very nice large galaxy. In addition, it was important to me that I have a reasonably fast telescope, because I want to photograph those fainter nebulae as well. I bought the telescope together with the Skywatcher EQ3-2 mount, and there are a few things that I need to say about this. First, the good thing about this mount is that it is an equatorial mount, so it is suitable for astrophotography. What it is less suitable for, well, astrophotography with a reflector telescope, because as it turns out, the mount is not sturdy enough for the telescope. I bought my telescope a mount about a year ago, so this is what I know now. But at the moment that I bought the telescope, I really just started the hobby, and yes, I did have these goals in mind, but I was mainly looking to learn how to work with a telescope and learn how an equatorial mount works, because, you know, there is a learning curve here. So for the very beginning, this was well, I would say a reasonable choice. Would I have bought the exact same mount at this point? No, but there will be another video about that on this channel as well. So we've talked a lot, and we have talked a lot about new topics, all related to telescopes and to the astronomy hobby. If you have any questions about this video, or if you want to know my ideas about something, then leave a comment below this video. If you like this video, please leave a like, and if you are interested in more of this kind of content, consider subscribing to this channel. Now, it's time to make some coffee, go outside, and look at some stars.